first page or the other page? First page, question number 5. A jet plane lands with a velocity of 115 meters per second, can accelerate at a maximum rate of negative 5.25 meters per second squared as it comes to rest. From the instant it touches the runway, what is the minimum time needed to come to a rest? Did you calculate that one? What'd you get? What was your number? Don't ever ask for help for a problem having had erased the work, because then you might have done it correctly and you don't know. So here we go. I'm just going to read it from here. Lands with a velocity of 115 meters per second and accelerates at negative 5.25 meters per second squared as it comes to rest. What do you know? Jasmine. What is it? Okay, so VI is 115 meters per second. This is number 5 out of the homework. VI is 115 meters per second. What else do you know? What's the acceleration? What else do you know? Someone said VF. Who said VF? Cohen, what's VF? 0. Why is it 0, Cohen? Because it's coming to a rest. So it's stopping, which means it's no longer moving, which means VF is 0. So now we've got all the pieces of information that we need, and we want to find, for part A, we want to find the time. For part B, we want to find, can this plane land on a small tropical runway where the runway is 0.950 kilometers long? So we can figure that out in a second here. Let's do A, though, first. Which of my kinematic equations, Jasmine, is going to relate VI, VF, A, and T? Which I don't have them in front of me listed, so what is it? Well, sounds like that would work to me. So that's going to be 0. This is going to equal 115 minus 5.25 t. No, the other one's squared. So we're going to subtract 115 over. We're going to divide by negative 5.25, and if I'm not mistaken, that's 12. Kirit, is that 12? You got a different? Oh, it was a different one you got 12 for. 21.1? 21. What? Oh, there it is. 21.9 seconds. There it is. Yeah, found it. Got it. The answer's there. So now part B says, can this plane land on a small tropical runway airport with a runway is 0.95 kilometers long? So, what do we do? How do we go about this? What are we trying to figure out? Naya, was that a hand? No. I'm trying to find the distance. We want to know what the distance that it actually takes the plane to land given this information. I should zoom this in so it's easy to read. So, I still have VI, VF, and A. Now I want to find D, so I'm going to use the other one. VF squared equals VI squared plus 2AD. VF is still 0. This is going to equal 115 squared minus 10.5D. I'm just doing the multiplication here already. 5.25 times 2 is 10.5, and it's negative. So 115 squared is not something I can do nicely in my head. So that's going to be 13,225. 13,225 minus 10.5d. So I'm going to subtract that over, and I'm going to divide by 10.5. I'm going to get that d is equal to a weird fraction. 1259.5. And that distance is in what units? So can the plane land? No. Because how long is that runway in meters? 950. So that plane not only is not going to land, it's going to end up like 300 meters offshore. That's going to suck for the people in that plane. That's number 5. Jasmine, does that make sense? Yeah. Any other questions out of the homework you want me to go over? From these first 9, let's do it that way. Any questions? 1, 3, 4, 5, 6, 8, 9 that you want me to go over? Yeah. Manuel, your hand was up first. Who wants number 9? Who am I talking to? Jasmine again? Okay. A car accelerates from rest at 6.65 meters per second. How far does it get between 10 and 14 seconds? That's a good question. What do we do? We know the acceleration. 6.65 meters per second squared. Is it? I don't know. Okay, so here's the situation. We're going to draw it out, which is actually going to make the question you asked me about the bonus question easier to actually visualize what's happening here. So we've got a car. It's a car, right? Yeah, it's a car. Slick car. Like a bug. And this thing's going to take off. At time 0, velocity is 0, and it's going to go. At time equals 10 seconds, we are going to start measuring the distance. This is what we want to figure out. So the acceleration is constant. That whole path, it's 6.65 meters per second squared. So what information and the part of the question that we're actually being asked about is this part right here. What's happening in this gap? So for this part of the question, is VI 0? No. What is VI? No, Manuel, we just said it wasn't 0. We don't know what that is, but could we find it? We could. Because the VI at 10 seconds, we could say is the V final for the first 10 seconds, right? So I could say that if I've got, for this chunk here, if t equals 10 seconds, if the acceleration is 6.65 meters per second squared, and my v is equal to 0, I can find VF. So VF is going to equal VI plus AT, which is just 0 plus 6.65 times 10, which is very nicely just 66.5 meters per second. Now that thing is hoofing it. Multiply by 3.6. Okay, so now we've got an initial velocity. That final velocity for this first 10 seconds becomes the initial velocity for this chunk of time here. So my VI is now, we've got a value for it. I'm just going to write it over top of that question mark. 66.5 meters per second. The time is going to be what? 4 seconds. And my acceleration now is going to be 6.65 meters per second squared. So this is actually what we're trying to solve for, and I want D. So which equation am I going to use? That relates VITA and D. You betcha. VI is 66.5. T is 4 plus 1/2 times 6.65 times 4 squared. If you run that, what do you get? Time this class end. 115. Okay. Sorry? Which is our first answer. That's great. Can someone verify?
Yeah, I got that.
Okay, cool. Yes.
So I did the question differently. I said the V initial was 0, and then I figured out the D for 10 seconds, and then I figured out the D for 14 seconds, and then I subtracted.
That works too. Yeah, you can do that too.
But is it wrong?
No.
Assume that V initial.
That's just not how that's just not how I initially thought of it, but you could do it that way. You could find the two different distances and then subtract them, sure. I found the initial velocity and then went for it that way. So I was a little quick to tell you were wrong to start with the VI equals 0. But that's another alternative, totally acceptable way to approach this question. Jasmine, is one of those ways work for you?
Yes.
You understand how they're both valid and different? Okay. As long as you've got one of them, just because I did it this way doesn't mean you have to do it that way. I probably would have seen yours and be like, oh, that's novel, I like it. I find it to be just an extra step, but whatever. I'm not going to judge you on that. You're good. Any other questions in the 1, 3, 4, 5, 6, 8, 9 section? 6. A body is traveling at 18 meters per second, comes to rest after undergoing a uniform negative acceleration for 40 meters. Okay. So what do you know? I think in the context of the question, a body just literally means some object, but it's way more entertaining to think of it as like an actual body. So a corpse is traveling 18 meters per second and comes to rest. Carry on. What do we know?
So initial velocity is 18 meters per second.
VI equals 18 meters per second. Carry on.
And the distance is 40 meters.
The distance is 40 meters. What else do we know?
Yeah, is 0.
VF is 0. Why is VF 0, Luis?
Because when it takes rest during of the trajectory,
Yeah, because the body comes to rest.
yeah.
Corpse is sliding along the ground, comes to a stop. Awesome to think about it that way. And you want the acceleration of the body. So if I want A, what equation relates VF, VI, D, and A? Okay, so we could fill that in. And then part B says, how long does it take to come to rest? So what am I looking for there? Time. Which equation relates VF, VI, D, and time?
D equals VI plus VF plus
There it is. Do you want me to actually fill those in and plug out the calculations, or are you good from here? You good from here? Okay. That's it. Okay, flip the page. There are more interesting ones on the backside. I wanted you guys to do one for the bonus and the super bonus. I'm going to give you the answers to those because those ones I weren't there for you. The answer to number 1, you should have found the acceleration to be equal to something in the neighborhood of 0.638 meters per second squared. Yes.
The number, the final velocity cut off, what was that?
That's supposed to be a 5. My apologies. Meters per second. Yeah, it's 5. I'll give you the answers to all of them for those of you who did some of the extra practice. The answer to number 2, if you want to look at it later, is 6 meters per second. The answer to number 3 is 7 meters. 4, which I assigned to you, is, what are we even looking for? What is the acceleration? I got 200,000? It's pretty decent acceleration. 200,000 meters per second. Number 5, I got t equals 20 seconds. If you want to go back and look at number 5. And now the bonus and the super bonus. The answer to A is yes. he hits the barrier. And all of the things that are involved in hitting the barrier. And then the super bonus is kind of gross, but not as, it's a little bit gross. The super bonus is the maximum speed at which the car could travel and not hit the barrier is a VI equals, let's give it to you in kilometers per hour because that's the same, that'll be the other one. I got 78.34 kilometers per hour. That is what you're looking for from this set of questions. Now, are there any questions that anyone would like to see? Good cure. Number the bonus. Okay, let's do the bonus. Does he hit the barrier? The short answer is yes. The long answer is how. So, VI is what? What's happening here? Sorry, hold on. Don't tell me about VIs. Answer my second question first. What's happening in this bonus question? Zaid, you started.
A guy is driving.
He's driving.
And then he takes a little bit of reaction time to start hitting the brakes, and then he's trying to stop before he hits the barrier.
So that's what that time is in there. It's not what you used it for as braking time. Because if you could bring your car to a stop in 0.75 seconds at 90 kilometers per hour, I don't think it'll cut you in half, but the seatbelt's going to crush your ribs. It's going to be you're still dead.
You like boxes, don't you?
Sorry?
You like boxes, don't you?
Oh, yeah, in physics, it's way more interesting to think about things, getting sliced and diced, absolutely. No, but even practically speaking, like thinking about what this actually means. If you're going 90 kilometers per hour in a car and stop in under a second, think about what your seatbelt's going to do to your body. I don't prefer corpses, but it's going to create one. Like, let's just be honest here. Though one of the most entertaining things I've ever read is an engineering analysis for Santa Claus. If you're interested in whether or not Santa Claus could exist, he could exist. I mean, you can believe in Santa Claus if you want. But I've got pretty firm mathematical proof that he burst into flames a long time ago. I can show you that later if you want. So, here's what's happening. We're going to draw it out like I drew out the first one. Car travels for some undetermined length of time. No, some undetermined distance, and that over that 0.75 seconds. And then he begins to slow down. For this chunk of time, how fast is Buddy going? This whole chunk of time, Buddy's going 90 kilometers per hour. Which is what in terms of meters per second? The conversion from meters to kilometers per hour to meters per second, what do I do? I hear divide by 3.6. It's cool, so that's 25 meters per second. So how far, I'll say it that way, how far does he travel in that 3/4 of a second? How many?
40 meters.
Nope, I hope not. Well, so this is he accelerating in this little chunk of space here? No. So which equation am I going to use for this time? No. D equals, Manuel? Velocity times time. There's no acceleration, it's just that constant piece. So we got D equals VT. V is 25, T is 0.75, so 3/4 of 25 is 18.75 meters. It's not looking good for Buddy Guy here. He's traveled almost half the distance and hasn't yet made an effort to slow down. This is bad news. So now, the second half of the question, so this is 18.75 meters. I want the entire distance. If that entire distance is bigger than 40 meters, buddy's toast. What is the initial velocity for this second chunk of the problem? Starting from here. VI is what? It's that same 25 meters per second. But now we have an acceleration. The acceleration is, thank you, Tristan, -10, which I think is also what Zaid said. -10 meters per second squared. That's this deceleration. VF is, in a perfect world, VF is going to be 0. And we want to find the distance. This is how I would approach this question. There is an alternative way to approach this question. Instead of saying that VF is 0, what I could do is I could say that my distance, this chunk here, is the 40 minus the 18.75, and see if he still has some final velocity. If Buddy still has final velocity after 40 meters, we know we should look away. Okay? That's the other way you can think about approaching this question. I don't particularly care how you choose to do it. I would do it this way. I want to know the total stopping distance, and if he's moving through the barrier at the time, then we'll figure that out pretty quickly here. So this is how I set that up. So the equation we're going to use is VF squared equals VI squared plus 2AD. VF is 0, VI is 25, square that, minus 20D. So 25 squared is 625. So it's going to be -625 divided by -20 equals D. We're going to get a distance there of, if I'm not mistaken, that's 31.25. Which looks good, except he's already gone 18.75 meters. So my total stopping distance under ideal conditions for this guy is going to be 49 meters. Does he stop before the barrier? No. Sorry? Look away. Or, don't. It's up to you. It's entirely up to you. Yeah, physics teachers, we all have our quirks. I had a physics teacher who hated cats. Hated them. Every question was about mangling cats in different ways. Every concept. Every concept. I had another one who I knew it. Actually, I didn't have this. He was a colleague who hated Miley Cyrus back when she first broke onto the scene. Lots of questions were about Miley Cyrus and Justin Bieber getting mowed down by cars, or if the car is able to stop in time, or every teacher has their thing. I just like to think about the practicality of the results that we're getting. Biologically speaking, he's dead. The physics is interesting. Applying the biology, way more interesting. Do you want to see the super bonus as well, Gerkiran? Okay. So, we want the maximum speed at which the car could travel and not hit the barrier. So we need this. I'm going to start with the second half of the question. So we need to know. Ooh, actually, this one's a little trickier. We've got a. Ooh. I don't like this quite so much. So, we want to know what the speed is, the maximum speed, so that she doesn't hit the barrier. So my time is still, it's the same setup here. Time is for that first piece is still going to be 0.75 seconds. The velocity, I'm just going to call x in meters per second. So we know that this initial distance traveled is 0.75x, because d equals vt. We cool with that? Okay. The second distance, if I go back up here and I rejig this thing, I'm just going to rewrite it. VF squared equals VI squared plus 2AD. I'm just going to solve it for d. That's 0. So this is going to be 0 equals x squared. The acceleration is the same, minus 20d. So then this is going to become x squared over 20 equals d. And what do I know about these two distances? To successfully survive, these two distances need to add to what? Not 39. Well, 39 would more than safe. If these two distances add to 40, Buddy is coming to a stop, and his bumper just ever so gently kisses the barrier. That's what these two adding up to 40 would mean. Just the most gentle of stops against the barrier, which is ideal. That is the absolute perfect scenario. So I want these two distances to add to 40. So I'm going to get 0.75x plus x squared over 20 equals 40. That looks an awful lot like what kind of equation? A quadratic, which some of you know how to solve and some of you do not, depending on your mathematical background. So I'm just going to multiply everything through here by 20. That's going to cancel that. So I'm going to get x squared plus, what is that, 15x? 3/4 of 20? Yeah, that's 15. Equals 800. X squared plus 15x minus 800 equals 0. That thing is not going to solve nicely. So you're going to want to use the quadratic formula for that. Hands up if you know what the quadratic formula is. Hands up if you've seen it. Quadratic formula. We do it in grade 10, yes? Is it first introduced in grade 10? Negative b plus or minus the square root of b squared minus 4ac all over 2a. It's grade 11? Okay. So if you've taken pre-calculus 11 already, here it is, like first semester. If you haven't, then I apologize, and I won't give, that's why it's a bonus question. So we can, it's A is 1, B is 15, C is negative 800. And if I'm not mistaken, when you solve this thing, you're going to positive and negative value. The negative value doesn't make sense because that means he's going backwards. So you want the positive value, and I found it, if I did my math right back in the day, 21.76175 meters per second was the value that I got, which I then converted for you guys to 78.34 kilometers per hour. So at this point, you've got pre-calc 11, right? So you can go verify this value, but that's how you proceed through it. The sticky bit being he travels a chunk of time before the brakes get applied, which is something that we often forget about, even in the real world. Like, oh, I can make that stop. Yeah, but reaction time is the thing. Not only do you have to process what's going on in front of you, you have to move your foot to the brake. So, any other questions about anything I assigned for homework? Going once? Twice? Some of you are still furiously, Naya and Kira, you're plugging away, yeah? Are you guys trying to verify this answer? Okay. This is also a place where if you had a quadratic formula programmed into your graphing calculator, I'd have no problem with you using it. Oh yeah. That's the thing. You're not allowed to use it in math class because they want to know that you can use it. But I don't care if you use the tools that are given to you here. This is not a math class. This is a word problem class. You use the tools that have been given to you other places. It's good? Okay. Sweet. If I asked you to dig a trench, and this was a shovel digging class, you'd have to use a shovel. But out in the world, I just want you to dig a trench. You want to get an excavator, man, go friggin' nuts. Use the tools. Okay, put your stuff away. Two questions. Put all your stuff away. You get the formula sheet. Put everything away. Because I want to see if you know this stuff. disgustingly easy.
I don't
If
even
you
remember.
didn't do it,
That's the problem.
you're gonna be seeing stuff brand new for the first time.
Well, I did the
Oh,
first
right,
nine
right,
questions.
right.
Oh, then you're good. Then you're good. If you did the first 9 questions, then you're set.
I think you have
Do we have the sword?
Right.
Or do we know?
What?
Yeah, you do it. Question 1, question 2. Hey, time off.
Yeah, you test it back then well.
We don't have enough formulas.
Wait, oh, in that way.
Okay, close your books.
Yeah, come on.
No, I love how he said nine, I was so happy.
This isn't two, oh, it is two, oh, it's 4 questions. Yeah.
Oh,
How dare
Well,
you.
it's 2 questions, it's 2 plus.
You always.
I really want
I
to.
know,
Question,
I know.
take them apart.
Wait,
I just need land to get a lot.
Do you remember the formulas? I don't. From like,
You do the shit after.
Roll
You
my
get the part of the sheet, everything else needs to be away.
yeah.
2 questions.
Oh, we can get the
Nice and
formulas?
easy.
Yeah, he said from my sheet.
Okay. Especially since the 2 questions you asked. So some of the questions you asked me to go over are in the quiz. It's great. So hopefully you're paying attention. You betcha. What? Apologies. Oh, right.
Yeah. This formula.
Yeah. Form the sheet, write that on the back. No, flip it over. Just do this. No. Just leave it like right there. I thought you did that. Leave it right like that.
Oh, this one.
You betcha we are. Rapping stuff. We did. Just be faster than community viewers. Show me all your work.